Welcome to Lesson 3 of our RStudio course. Today we're going to formalize how functions work. I'm going to show you the syntax of functions. We're going to run a few functions. You've already run them actually, but we're going to learn exactly how they're formed. And then we're going to maybe run a couple of graphs and operate on some numbers. In our last lesson, we declared some variables and assigned some values to them. We declared some single variables, single value variables, and we also declared some vectors, which are groups of numbers. So one variable represents a whole group of numbers. Remember that's just a list of numbers followed by commas and a little parentheses. And then we operated on these values, variables, and vectors in one way or another. And we're going to do more of that today. We're just going to learn the formal language of doing it. And of course, we have to print out the results so we see what we're looking up. With the very basic language of RStudio, you have to instruct it to display the information. You have to instruct it to give you an output. Functions are very simple commands which are situated in the computer language directly next to the the arguments. In statistics, they're called parameters. Situated next to the function is situated next to the numbers that you're operating on, like you're getting a mean or a median, or you're grouping data or ordering it. And the function is the command which does one or another of those operations. And when you type in the language to run a function, you type the name of the function, and then inside the parentheses, you add the arguments or parameters, which are the numbers you're operating on. It could also be variables representing numbers. So a function will operate on data, as we've already said. Anytime you're operating on data, finding an average or ordering it, a function is doing that work. Printing, graphing, exporting, summing, anything like that. And what happens is a function transforms the data and returns a value. That value can be called a return. It can be returned and printed out as a number, or you can assign it a variable name, which is more common. You can assign the result of the function a variable name so you can operate on it again in the future. Just like declaring variables as we did before, declaring variables from a function you assign in a right to left operation. The arrow goes from right to left. The arguments of the function, the numbers, are operated on by the function, and that little arrow exports the output, the return to the variable, which will hold the value of the returned value. So it's reading right to left, and think of it just as an equal sign. The thing is, the value on the right comes into being before the value on the left. That's counterintuitive for people who have a habit of reading left to right. And only a few items in RStudio operate on a right to left basis. Just think of it as a equal sign. But remember, the value on the right of the arrow comes into being first. That's not really important at the moment, but later on with higher level stuff that will be important. Okay, so let's look at some functions. We've already used the concatenate function. Remember, C for concatenate in the first example takes those three numerals and assigns them to the variable named Simon. So from now on in the program, Simon will represent 3, 8, and 99 in a group. Second one, on the right-hand side, we're taking the mean of Simon. We're taking the mean of those three numbers and assigning that value the variable name Rachel. And then we're printing Rachel. We're displaying it to the output screen, the console. So these are three functions: concatenation, and then finding the mean, and then printing. And as you see, the function is on the left of where the value being operated on is. And in the second two lines, the numbers are represented by a variable which we declared in the first line. Okay, the concatenate function is slightly different from what we saw in a spreadsheet, for example. In a spreadsheet, when we do a function, we just do equal average to get the mean and then enter the numbers separated by commas. I made a slight mistake. I omitted a comma and turned 44,55 into 44.55. It's a trivial error. I just transformed two numbers into one number with a decimal place, but it still functions just fine. But with R, we need to put a little C concatenate in the when we group the numbers, and then we enclose that in parentheses, and then we add the mean function instead of average. So this is what it looks like when typed into the RStudio text editor. Same language from 2 slides ago. And at the bottom is the output. Line 3 of the text editor sends the value of the mean of the numbers to the console. And the source button in the text editor runs the command to print out the value of Rachel, which is the mean of Simon, Simon being the concatenation of the three digits in the first row, your vector. We could also streamline the process by not assigning the mean of Simon to another variable and just print out the mean of Simon. That's the second group of commands there on the page. What we've done is put the function that gets the mean of Simon inside a separate pair of parentheses and told the console to print that out. This is called nesting a function, or chaining command, nesting a function inside another function. It gets complex. You'll see there's lots of parentheses around. It's a little difficult to read, but it's quick. If you didn't need to assign the value of Simon, the value of the mean of Simon to another variable, you can just nest these commands. The important thing is that you honor the logic and the syntax of the function. Again, this is called nesting a function. You have to honor the number of parentheses, make certain they match. In the lower left-hand corner, you'll see one of the outer parentheses is missing and you're getting an error message. The vector 3, 2 is concatenated with one pair of parentheses, and that function is enclosed inside another function which gets the mean, which encloses the first function inside a second pair of parentheses. However, in the lower left, we're missing one of the parentheses, and hence you get an error message. On the lower right, you'll see as you're typing the thing in, the text editor will automatically add all the parentheses you need. It knows this in advance. Whenever you type in a parenthesis, it types a matching right parenthesis to make certain that you get them correct. And unless you accidentally delete them, delete the right parenthesis or put a comma in the wrong place or something, it will save you from making errors, and you don't have to count parentheses. You can also, instead of concatenating a vector made of numbers, you can concatenate a vector made of variables. We assign a value to each one of the variables, and then we put the variables inside inside a vector, which we concatenate. Then we take the mean of that. So we've had 3, 4 total variable assignments. You don't need to always just put in numbers, and that way the great thing about variables is you only have to change their value once, and you can run the same values over and over again in different contexts later on. Variables are a great time saver. This is what it's like when you run it in RStudio. 3 variables with values attached, and then those 3 variables put inside, concatenated inside a vector. The mean taken of those 3 variables, that mean assigned to a variable Tom, and then Tom printed out in the console below. Here are some other basic functions. Sum, you can sum any number of numerals in an unordered list separated by commas, and it will return the sum of all those numbers. Notice you don't have to concatenate that. You don't have to concatenate that into a vector. Just type in sum and a bunch of numbers, and it's a simple enough operation that it will simply return those values. You can get the median of a set of numbers. You have to concatenate the set of numbers into a vector first, but then you can nest that inside a pair of parentheses and get the median or the mean. You can sort. The sort command will return the vector in numbers, smallest number to biggest. You can reverse it and sort a vector in descending order as well. However, when you do that, you have to, whenever you're doing the decreasing, see the 4th example, the little comma decreasing equals true, orders the sorting to be reversed, overcoming the default tendency, which is to sort a vector in ascending order. You can't do all of that while concatenating a vector at the same time. You have to have previously concatenated the vector and given it a variable name, just to make it less complex. So time, in this instance, imagine that's a bunch of numbers concatenated already into a vector with the name time. So you cannot get increasingly complex here and have concatenation and the language which reverses the sorting order, and then put that all inside another sort function. That's too complex. And here is what we have when we do the previous functions on vectors. Upper left-hand corner, you'll see the programming in the text editor. Lower right-hand corner, you'll see the console output. First instance, we're summing up 4 numbers using the sum function. We're assigning that value to cat. The function sum returns the value to cat. Second one, we're concatenating a bunch of numbers and then getting a median of them and assigning that value to dog. Median, of course, is the middle value. Then we're sorting a set of numbers that are concatenated into a vector and returning that value to snake. That will be an ascending set of numbers. And then the fourth one, well, first we have to create a vector called time. I'm going to concatenate a bunch of numbers and call that the variable time as a vector. And then badger is going to be the sorting of the vector time in decreasing order from biggest to smallest. So we've defined a bunch of functions, assign their returns to variable names, and then just at the bottom of the text editor, we're printing them all out. You can see the outcome in the lower right window, the console. First one is just the sum of those numbers. Second one is the median of that bunch of numbers. Since it's an even set of numbers, even number of numbers in the concatenated vector, it's actually taking the midpoint between the 2 middle values. The third one, we're sorting 4 numbers in ascending order. The third one, we're sorting 4 numbers in ascending order, and the fourth one, we're sorting 5 numbers in a descending order. So those are all functions. We're using nested functions, as I said. For inner one will be a concatenation of numbers. The outer ones will be some kind of function which operates on them, and then we assign that output to a variable and print it out with a printing function. I know that's a lot of information, but functions are pretty simple. Name of the function followed by the information to be operated on in parentheses. That's the principle you need to know. And the output needs to be printed out in some manner so that you can see it, know that you're doing the right thing. So let's do a quick sneak peek at graphing, which is just another function that's very simple. Graphing is really the heart and soul of what you're doing with R, because putting numbers in a graph makes everything much more relatable. It's a lot more fun, and it's very simple to do. With a graph, we're going to be graphing points in a Cartesian plane. We'll have an X value running along the horizontal and a Y value running in the vertical. And those 2 values will define a point in a plane. And a bunch of points can be used to show a trend line, especially if we connect them. So we use the plot function to define some points on a plane. We specify what data is to be plotted, what vector name is to be plotted. And we can use the line function to draw lines between points. I'll show you exactly what I mean. So here we have two values, time and temperature, two vectors. It's very important that you have the same number of values in each vector. Otherwise, you'll have a point that is missing an x or y coordinate, and that will make no logical sense. The time, I made the time series along the bottom. For some reason, it doesn't show up in this slide, but the other slide, the slide graphic does show up time running along the bottom. Along the side, on the y-axis, you have temperature. So time is a set of values ascending, and temperature that varies along those temperature at instances matching those times, those time intervals or time points. And so you've got two vectors, and then it's very simple. You do plot, time, temperature. Plot with time and temperature, the arguments of the function inside parentheses. Time and temperature are the two vectors above, and you'll see you get 5 points in this graph. Each one will have the x value which matches time and the y value which matches temperature. So for the first one, you have time value on x axis value 14 and y axis value 22. Second point, you'll have time value on x axis 33 and y axis 33 as well. It looks a little off on the x axis actually. The third one, 55, kind of close to 60, but back down to value 21 on the y-axis. So you have 5 points there. Each one, the time is expressed as the x value, and then the temperature is expressed as the y value of each point. And plot time temperature is, think of it as plot x comma y. X-axis is the x value, y-axis is the y value. As you see, temperature varies as time scale progresses. So the function form, as I said before, is plot, and then the vector you want running along the x-axis first, and then the value you want running along the y-axis second after the comma. And that's it. You get a nice, very simple graph. And you'll notice the axes match the name of the vectors. That's automatically done, whereas sometimes in Excel you have to go in and change the names, and it's a real pain. It's automatically done for you here. And using the function lines, time, temperature, will draw lines between the points. So you can get a trend line, make it much more visible. Also, we can add, in the plot function, we've added xlab and ylab equals, and those are labels for the axes. That's optional. In the previous graph, we just had time and temperature, but in this next one, we have added time in minutes to make it easier to discern why the plot is running the way it is. And so lines is very useful because that'll allow you to create a better looking time series. So in summary, um, today we formalized our definition of what a function is. Um, we know that it's a bunch of numbers inside of parentheses and then a function to the left of it, which defines what you're going to do with the numbers. Very simple. Um, the function operates on values, which are either typed in directly or represented by variables, or represented by a concatenated set of numbers represented in one variable, um, called a vector. We learned that functions can do all kinds of things to numbers. Um, we can average, we can sum, we can put them in order. Um, every operation we do on numbers really is a function, including printing, that's a function, graphing. Um, those don't do anything to the numbers, but they display them. We took a look at uh, graphing very simply. We mapped some points, x value in one vector, y value in the other vector. Make certain you have an equal number of to equal number of values in each vector so that uh, every point gets all the values it needs. And then you plot them, and you can draw lines between them, and you can rename the axes. Um, and that's the real heart of the matter. Everyone loves a graph, makes things easier to uh, figure out and uh, makes things easier to understand. So, thanks for watching. Look out for the next episode, and we hope that we're making it understandable. Have a good day.